Let's take a look at this question from Larson's calculus. So we're given two equations, one of a hyperbolic paraboloid written over here, and then one of a plane, and they're asking us to find the intersection of the two. So let's see how we can do this. And the first thing that you might notice is that we've got z to the first power, to the first degree, and then same thing over here. So let's just equate the z's, right? So on the left hand side we have z is equal to y squared over b squared minus x squared over a squared. And then on the right hand side we have bx plus ay is equal to z, right? That's an equivalent way of writing it. So z is equal to bx plus ay. You can set the two sides equal to each other now. So we're going to get bx plus ay is equal to this thing over here, y squared over b squared minus x squared over a squared. And there are a few different ways of kind of figuring this out. But one way to do it is just to cross multiply the right hand side. So we're just going to focus on that for a bit. We get a squared y squared minus b squared x squared, all divided by a squared b squared. Let's now use the difference of squares. So the top part is going to be ay plus bx, right, times ay minus bx, all divided by a squared b squared. So that denominator does not change. Let's go back and put on our left hand side, which is bx plus ay. One second, bx plus ay. Okay. Now what we can do is divide both sides, right? We see a bx plus ay in common, bx plus ay over here. We can divide both sides with that, just assuming that bx plus ay does not equal 0. So essentially b should not equal negative ay over x, or a few different ways to write that, but we're just going to make that assumption and divide both sides. And that gives us, so when you divide both sides of that, you get 1 is equal to ay minus bx over a squared b squared. That's kind of enough for a solution already. We can just multiply both sides by a squared b squared though. And so we're going to get ay minus bx is equal to a squared b squared. Now you can try to solve for this explicitly in y, and let's actually go ahead and try that. So we're going to add bx to both sides. So ay is equal to a squared b squared plus bx, and then we divide everything through y and a, which gives us y is equal to dividing a squared b squared by a just gives us ab squared and then b over a x, and with that we are done. So there, actually you don't even need to go this far. You could have stopped over here, that would have been fine. You could have also stopped over here. The main thing to do is just making sure you know how to do the algebra, right? And it's pretty straightforward, so you don't need to know anything about the hyperbolic paraboloid. It looks something like this. Sorry, that's a hyperboloid of two faces. This actually would look like, I guess the best way to describe it is like a Pringle, and a plane of course is just something like this, right? That will extend forever in these directions, right? A plane is like the Cartesian plane, but this will look like a Pringle, so it's going to be very, very difficult to graph. Like I've tried to draw it on paper and that's terrible enough. Like if I tried to draw it here, it would look like, I don't know, I guess, yeah, it looks terrible, but it's a very difficult shape. So just being able to do the algebra, that's a pretty important skill. So hopefully you got some practice with that, and I'll see you in the next video. Thanks for watching.